For this experiment, we will need a Geiger counter, a radioactive source, an interface to connect up to the Geiger counter that will make all the counts, and for the information to be displayed, a calculator. Here is the Geiger counter that we will be using in this experiment. Now, this is the program that we'll be using in this experiment. And we'll begin by measuring the background radiation. Which is number 2 here. And we'll collect background radiation for 3 minutes. So here is the background count, 11 counts per minute. And this will be applied to the data as we progress through the experiment. Once the background radiation has been measured, we slide the radioactive source underneath the Geiger counter and then begin the experiment. Now we begin the experiment at time 0, and we'll be using number 6 here, a single interval time, which will measure the activity of the indium-116 in counts per minute. Now we're coming up to 4 minutes into the experiment, and at 4 minutes we're going to count the radioactivity for a 1-minute interval. Now at 4 minutes into the experiment, the activity of the sample is 64 counts per minute. Now 20 minutes into the experiment, the activity of the sample in counts per minute will be measured. So after 20 minutes, the activity of the sample has dropped to 51 counts per minute. So after 36 minutes, the sample has an activity of 42 counts per minute. So after 52 minutes of activity, the sample has 35 counts per minute. So after 68 minutes, the activity of the sample is 26 counts per minute. So after 88 minutes, the activity of the sample has dropped to 21 counts per minute. So after 108 minutes, the activity of the sample is now 11 counts per minute. Now, after 124 minutes, the activity of the radioactive sample is 18 counts per minute. Now, at 140 minutes, the activity of the sample is 13 counts per minute. Now, with this data and the sheet that accompanies this video, determine the half-life of Indium-116.